Thank you all very much for coming today. We're really excited to be able to talk with such a wide range of folks today from a variety of different backgrounds. And so this first picture here is taken from just inside the gate of the Davis Mountains Preserve, which is really where this research focuses. And you can see here, this is sort of an intentionally cleared out area that's been kept open from burning and thinning, and a lot of the management area is, and environmental education center is here. But the main point of this slide is to sort of show you the range of physiography and forest cover that you see inside the Davis Mountains Preserve. And in the background here is Mount Livermore. That is also within the preserve, and that's the second highest peak in Texas. And so you can see from that that it's a pretty big preserve, and it covers a lot of ground, and it's pretty topographically dissected as well. And so just as a little point of background, as you saw in Xander's presentation, this area here was in white, right? So we're actually really excited that the Southwest Fire Consortium is including this region as part of their consortium, because if you go to the Texas, or mountains in West Texas, you'll see that the vegetation is pretty similar to a lot of the other Sky Island systems that you see in southeastern Arizona and southern New Mexico. And so this part of Texas is really sort of nestled in underneath New Mexico. For a point of reference, if you've ever been to Big Bend National Park, that's down here. That's also one of these Sky Island systems that you find in the northern Sierra Madre Oriental. So the difference is that this is the other major mountain range in Mexico that starts to break apart into these mountain island archipelagos in the southwestern United States. So in southeastern Arizona and southern New Mexico, you're in the Sierra Madre Occidental. This is the Sierra Madre Oriental. But the species composition and the look of the forest is really very similar to a lot of the other locations of the southern part of the Southwest. Now, like other Sky Island systems, low elevation grasslands bound the site, and as you go up in elevation, you get increases in tree density and vegetation cover. So for the next few slides, since we're sort of the first people to present from this region, I wanted to just show you some pictures so you could get a sense and a feel for what the place looked like. So at lower elevations, you have this pinyon, juniper, oak, woodland scrub, and so that includes things like bear grass and sotol and other catclaw, and then also small stature junipers and pinyon pines. It also has a pretty large oak component. So this is an example of a stand of oaks that you would find in the Davis Mountains. And so like other Madry and evergreen woodlands in other parts of the Southwest, you have that pinyon, juniper, oak complex that's found throughout the entire Davis Mountains Preserve. Now at higher elevations and in mesic drainages and high elevation north-facing slopes, you start to get other species, and those are principally dominated by ponderosa pine and southwestern white pine. Southwestern white pine is really more on the higher elevation north-facing slopes, but the drainages are comprised of ponderosa pine, of course, with these other oak associates and pinyon pine and juniper mixed in. The important thing about this vegetation type is that it is rare for the Davis Mountains. So it's really restricted to these drainages and high elevation wet sites, whereas most of the Davis Mountains is comprised of these pinyon, juniper, oak woodlands. It's also kind of an interesting note that Douglas fir is absent from this preserve. So it is found to the north and to the south, but it didn't make it during the time of glacial refugia to this site. So you won't see Doug fir in this location. But you do see lots of pinyon pine, and so this is more of a low elevation, open pinyon juniper woodland, very grassy understory, scattered trees. But then, tree density can change quite a lot. You have much more dense stands at higher elevations. We also have manzanita. We've got all the usual suspects of agave and prickly pear cactus that you're all used to seeing in other places in the Southwest as well. And then in terms of individual species, we have a range of species that are both regenerate by seed, principally pinyon pine and ponderosa pine, and also in all of the other pictures in this slide are pictures of species that resprout. And so that's really important when you think about not only fuels management, but also when you think about post-fire response. And so here, one of the major differences that you'll see in these forests relative to the rest of the Southwest is that this is gray oak, Quercus ricea. That really fills the functional role of something like Arizona white oak, Quercus arizonica. It's a site generalist. It's found across the entire elevation gradient. It sprouts prolifically after fire, as does emery oak. So emery oak is another species that's pretty common in a lot of different sites in other madryn evergreen woodlands, as is alligator juniper. Now, alligator juniper is one of the sprouting junipers, and so that's also a management challenge when that is one of the species that has been regenerating in the absence of fire over the last few years. But we also have a madrone, which also resprouts, and it's obviously everybody likes a madrone. It's a favorite tree because it's pretty rare. This one is the Texas madrone. So, like I said, ponderosa pine regenerates by seed, but it's a thick bark species. It's a fire resistor. So with that, that should give you kind of an idea of what types of trees we have there and what it looks like in comparison to the places where you all work. So one of the things that I did for my dissertation was to reconstruct the fire history and look at the age structure of the forests there. And this is for pinyon pine specifically. And if you look at the mean fire return interval, you can see that fires happened about every 10 years or so on the preserve, somewhere on the preserve. The point fire return interval suggests that a tree experienced fire at its base approximately every 75 years. So these are pretty long fire return intervals in comparison to like a ponderosa pine type forest. But the interesting thing that you'll see from this that is pretty different from places like Mesa Verde where Lisa Floyd-Hanna has worked is that if you look at these individual tree records, there were trees that experienced multiple fires at their base and survived them. These are pinyon pines, so it's kind of unusual in that respect. And this is a real topographically dissected landscape. So this is somewhat interesting because this suggests that a low intensity surface fire regime that was fairly frequent was common in this location. And then you also have sort of the coincident increase in tree establishment after fire started to drop off. Now, I don't know how well you can see this number here, but this is the last major, oops, that's the wrong button. Okay, the last major fire event was in like 1926. So that is much later than other places in the Southwest where you're looking at fires dropping out of the system in the late 1800s and early 1900s. And that basically has to do a lot with the fact that this area was used a lot up until 1997 for goat ranching, and it was those goats were brought in after the big drought and the end of the cattle boom in the late 1800s. So once we finished sort of looking at how fires happened historically and what kinds of changes have happened in the absence of fire due to fire exclusion from grazing, I was working with folks like Charlotte and managers on the preserve to think about what kinds of fuel management activities or fuel management alternatives are out there for dealing with or mitigating the possibility of a subsequent wildfire event. And so we used the National Fire and Fire Surrogate Study sort of framework of looking at prescribed burns alone, thinned areas alone, and then thinned plus burned areas, and then control areas to try to understand how those different types of fuel management alternatives played out on this landscape particularly. There are quite a few other studies, and some of you guys are online right now, who've looked at pinyon juniper woodlands. But we were trying to look at some site-specific locations, and trying to generate some local experiences about how this played out on the landscape. Now, when we implemented the treatments, prior to treatment implementation, we used permanent fixed area plots. So we put rebar in the center of the plots, we tagged all the trees, and we inventoried trees by species, took their DBH, live crown height, total height, etc. And then we used nested circular plots to tally seedlings by species. And then at a random azimuth, we inventoried fuels using brown lines. And so we did that all prior to treatment implementation. That was basically the summer before. And then over the winter is when the treatments were established. And so, these treatments were really established in using kind of a risk-averse implementation. And so they were using pretty small diameter caps. And so we're talking about 6-inch diameter caps for the thinning 80% of the trees below 6 inches DBH. And then the fires were done in like January and February outside the fire season. And so, and then we went back and resampled them the following June, so within 6 months of when the treatments had been implemented. And then I used a mixed model analysis in order to look at before and after effects on above ground and surface fuels. And so basically what we found is pretty consistent with other work, which is that the thin only and the thin burn treatments were the ones that had significant influences on the size class distribution of the trees. So up to about 25 centimeters DBH, we had significant changes or significant drops in tree density. And whereas the burn-only treatment, you don't see any asterisks there. That means no significant effects. So that really fleshes out the importance of post-fire resprouting in terms of vegetation response. And again, these were these were low-intensity surface fires that were done in the winter. So you wouldn't necessarily expect there to be a huge post-fire response anyway in terms of mortality. And that certainly came out from the results of this study. So with that, we also looked at surface fuels, and so the same thing happened, sort of the opposite happened, right? So thinning treatments were the ones that reduced above ground fuels, while surface fuels increased in the thinning, any of the treatments involving thinning. And that is due to the fact that they used a lop and scatter rather than a mastication or pile burning method for dealing with the fuels. So the results of this research sort of suggest that, if you're going to use conservative methods for the fuel treatment implementation, you're not going to have really huge results. But the interesting thing comes after that when we talk about some wildfires that went through. And so now I'll turn it over to Charlotte to talk about the wildfires in the Davis Mountains.
Thank you, Helen. So Helen had done all of this great work constructing fire histories, doing all of this fire and fire surrogate work. And while we were, as managers, were still kind of digesting it, in 2011, Texas entered the most severe one-year drought since I've been keeping records in the late 1800s. And during that drought, we had 3 wildfires that burned across the preserve. The first one, the largest one, was the Rock House wildfire that burned more than 300,000 acres. It started in April. It took them about a month to get everything contained. And everybody was still catching their breath when the Tejano Canyon fire started in June 2011. That burned an additional 12,000 acres. And then about a year later, in April 2012, we had the Livermore Complex fire. This is a map of the 3 fires. It only shows a very small portion of the Rock House fire. It burned a very large area quite distant from the preserve. And you can see that all 3 fires burned fairly large areas of the preserve. We do have some parts of the preserve that didn't burn. And an interesting note about these wildfires, because even though the Livermore Complex fire, the one in yellow, burned about a year later than the other ones, we were still in a drought, and the trees really had not grown in that time. And from a fire scar perspective, all 3 of these fires would have shown up in the fire scar record as one single very large fire. And so that shows you when you do fire scar work, there's always some limitations, but it's also interesting to think about how many of the large fires that were recorded in the fire records may actually have been several smaller fires. Now, Helen had installed a grid of vegetation plots all across the preserve, and so we have plots that burned in each of the 3 wildfires, and also plots that did not burn in any of the wildfires, which gave us a really nice setup because we had data from what these areas looked like before the fires. We had areas where we had done no field treatments. We had areas where we did all of the fire and fire surrogate stuff. So we were very excited once we caught our breath after the fires about the opportunity to use all of this data and figure out what was happening on the preserve. These are some pictures from the wildfires. The Rock House fire in particular, fire behavior was extreme. As I mentioned, it took them more than a month to contain it. I pulled resources from all across the state, and it was one of, not the largest fire in Texas history, but one of the largest ones that we've dealt with. So our first question after all the smoke cleared from these fires was what was going to happen to our preserve? What would our vegetation look like? What would habitat for all the wildlife look like? And so we were very interested in going back and collecting some more data to try and figure that out. Then we had put in a lot of work doing all of these field treatments, and we wanted to know whether those field treatments made a difference. And if they did, whether there was one field treatment that was particularly effective, because that would then be the one that we would want to continue implementing on a larger scale across the preserve. So after each of the fires, we went back within 6 months, relocated the plots, tried to relocate as many of the tagged trees as we could. There were instances where we went to plots and the trees were completely gone. In most cases, we could find the majority of the trees, mark them as living, standing dead, or dead and down. We recorded live crown height, various fire severity measures like char height and scorch height. We recounted all the seedlings to look at regeneration. We redid all the brown lines. And then we did a mixed models analysis to look at the stem density data and the basal area data, and also some non-metric multidimensional scaling to look at changes in species composition.
Charlotte, let me break in for just 1 second. Dave asked a good question in the chat window about whether there was any overlap in those 3 fires that you addressed, and did you have any plots in that overlap?
There was very minimal overlap between the 3. For the most part, I'm not sure whether they used the same road lines to control them, or if it was just that when the fires hit the previously burned areas that they just stopped burning. But the overlap was minimal, and as far as I know, we don't have plots that burned in more than 1 fire.
That's correct.
Okay, great, thanks.
So these are some photos from our plots after the fires. You can see they range from areas like the one in the top left, where most of the trees survived the fires. We had other areas like the top right where we had a little bit of scorching. And then these 2 pictures in the bottom, you can see much higher fire density where the majority of the trees were killed. Here's another photo showing more of a landscape view. Helen mentioned that the ponderosa pine and the southwestern white pine in the Davis Mountains are generally confined to the drainages and the side canyons. Because those areas are more mesic, stem density tends to be higher, and you can see how the fire followed these canyons up the slopes and really concentrated on the vegetation types that we are most concerned about. You can also see how quickly fire severity changed from one location to another, where you go from an area where all the trees were killed to areas where the canopy was largely unaffected. This picture in the top right was taken less than a month after the Livermore fire, and you can see that there was some large pines that were killed, but also that less than a month after the fire that the oaks were already resprouting. So the regeneration potential of at least our resprouting species didn't seem to be decreased by the wildfires. Here's some more pictures. These are from the same plots. These are from areas that did not receive any pretreatments. On the top, you can see one of our lower elevation areas where a lot of the trees were killed, but in the background you can see a few trees that survived. The bottom pair of pictures shows a slightly higher elevation where we have some oaks. And you can see a lot farther after the wildfire. This is an area that burned with higher severity, and most of the trees were top killed. These are some photos from one of our field treatment areas. This was a thin burn area. So you can see the pre-treatment photo. The middle one is after the treatments were implemented. Those photos were both taken in fairly dry years. You can see that there's fairly little ground fuel. And then we have a photo 1 year after the wildfire. And you can see most of the trees in this area survived the wildfire. And we've also had some very nice rain this summer. And our herbaceous understory has been responding very nicely to that rain. And now I will turn it back to Helen to talk about some of the analysis results.
Thanks, Charlotte. So do you want to give me, oh, there we go. All right, got control back. So as Charlotte showed, that there was a lot of variability in terms of the wildfire response. And even though these fire and fire surrogates treatments were implemented in a way that was not, where they were not thinning huge trees and where we were not burning in season, you see that in terms of changes in tree density and basal area, the wildfire-only treatments were the two groups that had significant changes in basal area and tree density. So that's really interesting. That's sort of the big surprise from this work, is that it made a difference to treat these areas, and all of the different treatment groups responded where you had lower tree mortality in places that were treated and places that were not treated. Now, if you look at this, also if you look at the thin plus burn plus wildfire changes, they are the least. So you have the least change with the least tree mortality in places that have been thinned, plus burned, and then experienced wildfire. So that sort of follows a lot of what's been found in the rest of the Southwest, just saying that it's the most effective in terms of altering forest stem structure and fuel loads. And then if you have a subsequent wildfire, it actually looks like it experiences the least change in terms of forest stem structural response. And so then if you go and you look at the size class distributions, well, you see the same thing as before in terms of what size classes were affected, but all of these little asterisks here on the wildfire-only treatment group, you can see that all of the size classes up to about 25 centimeters DBH, so about 10 inches diameter, experienced significant mortality in places that had not been treated, whereas in the other different treatment groups, you didn't see that effect. And interestingly, you did see, however, in the pole-sized trees for the burn plus wildfire and the thin plus wildfire, you do see, oops, well, I move my arrow here one more time, you do see significant mortality in the small size classes. So from a management perspective, a lot of times those are the trees that people are targeting to try to thin out to reduce the risk of subsequent fire. And it looks like the wildfire actually did that. And so that was kind of an interesting effect in those two different treatment types. And so then in terms of seedlings, basically it comes back to this whole, does the tree resprout after fire, or does it regenerate by seed? And species that had regeneration by seed, ponderosa pine, pinyon pine, and there should be a a bar here that goes up here, up a little higher. I just realized that that wasn't there when I was going over the presentation, but that those species were the ones that had significant declines in seedling densities, whereas some of these other species like gray oak, for example, that resprouts pretty vigorously after fire, had increases due to post-fire resprouting. And so just to give you a sense of kind of how that played out for both that species and, say, alligator juniper, if we had a tree that was top-killed but was just sprouting at the base, that was then tallied as a seedling. And so that was just sort of the systematic or standardized sampling protocol that we used. And so that's why you'll see this increase. And so with that, you'll also see that there's a difference between alligator, juniper, and gray oak, and a lot of that has to do with the post-fire sprouting ability. So if you've ever walked through some of these fires, even the higher intensity fires will kill alligator juniper, but for example, with silverleaf oak, I've seen within months you have these huge thickets of silverleaf oak, even in high intensity fire areas. So the sprouting ability also had a lot to do with the seedling response. And then lastly, we looked at changes in species composition. So this is basically looking at species importance values of basal area and tree density. And you see that treatments involving thinning had higher shifts in species composition than treatments that did not involve thinning. And so there's a couple of things going on there. Obviously, the thin plus wildfire, the thin plus burn plus wildfire, and the thin plus wildfire, they experience fire, so you have a shift towards some of these post-fire sprouting oaks. But also, when they were doing these thinning operations, obviously some of these species of interest, like ponderosa pine, were not thinned as aggressively as some of the other species like juniper and oak and pinyon pine. And so, however, there was a lot of ponderosa pine that was thinned, but that was kind of the explanation that we came up with why the change in species composition for those two treatment types. So, that's basically, this is really a work in progress. We just finished collecting the one-year data for the Livermore fires. So we have, this is what we've presented to you thus far is basically the pre-fire, the post-fire data. But we have all the one-year data, and so we really want to try to capture that delayed mortality effect and look at how things have changed over the longer term, both in terms of live fuels, surface fuels, and then also species composition. We're going to look at other stand structural attributes like live crown. So did the live crown height change? Did it rise vertically, which would make these forests less susceptible for a surface fire to move into the crown? And then also we have all the fuels data that we haven't had a chance to quite look at quite yet. So those are sort of the results, and then I'll let Charlotte talk about the conclusion.
Thank you, Helen. So as Helen mentioned, going through all of these graphs, we were gratified to find that all of the fuel treatments we implemented reduced overall tree mortality. And the effects that they had were particularly focused in trees between that 10 centimeter and 25 centimeter DBH classes, so the pole-sized trees or the slightly smaller trees. The large trees, even in the untreated areas, in general survived the fires, although, as you saw from those pictures, fire severity varied greatly across the landscape. It was also important for us to find out that thinning can change species composition, and you can use that to your advantage or your disadvantage depending how you implement the thinning, but that is something to keep in mind if we do implement more thinning treatments, that we need to be cognizant of how we're implementing those and making sure that if we are shifting species composition, we're doing that to favor the species that we in fact want to favor. All of that being said, there are some confounding factors in this study. Clearly, these wildfires were not planned, and so you always have the messiness of different numbers of plots burned in the different wildfires and not being able to control that. But these three photos are all from areas that did not burn in the wildfires, and you can see that there are quite a number of dead trees. As I mentioned, these fires came in the midst of a very severe one-year drought, and there was also roughly halfway through that drought in February 2011, there was some very cold weather, unusually cold for this part of Texas. And we suspect that the combination of the unusual cold and the drought may have killed some trees. We've also had bark beetle outbreaks that seem to hit our ponderosa pines particularly hard, and that's in this upper right photo. You can see the ponderosa pines and the drainages, and this photo on the bottom left, again, that slope, that is a lot of ponderosa pine on that slope. But the photo on the bottom right, even on our lower elevation slopes, there are areas where we have dead pinyon pines and dead junipers from the drought. So we're taking a look at all of these factors, trying to tease apart what's going on in the unburned areas and what's going on in the burned areas. And that's why it's so important for us to have plots in the controlled areas, because some of the trees that were killed by the wildfires were either dead already or would have died anyway. So it's important for us to be able to account for that. So the take-home message for those of us who are helping to manage these preserves, the wildfire accomplished a lot of thinning for us that would have taken us many, many years to do mechanically or with prescribed fire. And in that sense, it helped our management. The areas that burned in the wildfire seem to be more fire resistant. As we mentioned earlier, there was very little overlap between the fires, so it does seem like the decreased stem density in the burned areas may help us manage future wildfires. The wildfire thin stands may also be more drought resistant. With lower tree density, there's fewer trees that are competing for the available moisture. However, we do still have areas that didn't burn, and those areas still have very high tree density, and that is something that we need to look at, because these will not be the last wildfires that we have in the preserve. And a lot of the areas with the highest tree density are in our mesa canyons, and we're very concerned about these mesa canyons. We have several rare plant species that are found only in the mesa canyons, and we're also expecting these canyons to be important as climate refugia as temperatures increase. Compared to a lot of other sky islands, the Davis Mountains don't have a very large elevation range. Mount Livermore is just over 8,300 feet. So most of our plant species don't have any higher to go in the elevation. The Davis Mountains is already acting as a climate refuge for them. So we're actually expecting a lot of these species to move down into the canyons and following the moisture gradients rather than the elevation gradients. And so we need to think of strategies to protect these canyons from wildfire, whether that involves thinning in the canyons themselves or thinning adjacent areas to reduce the risk of wildfire reaching them. And also in general, thinking about applying our field treatments across the preserve. Thinning works very well. Thinning plus burning seems to work particularly well, but it's very difficult for us to apply that treatment on a topographically complex landscape over many thousands of acres, and so we're still trying to figure out the logistics of doing that. And with that, Helen and I will take some questions, and I've seen a few questions pop up in the chat box already.
Yeah, well, first, this is Andrew. Let me say that that's an excellent presentation. I really thank you guys for clearly you spent some time putting that together and practicing, and so it was really top-notch. And in 1 second or two, I'll unmute the line, and so people can ask questions just verbally over the phone. So if you've got something going on in the background, please make sure you either turn it off or mute it or something. But in the meantime, maybe we can take a question from the chat window. and Dave has asked for a little bit more commentary, maybe not from the data itself, but maybe just from your experience about the lack of overlap between the fires and whether it was related to suppression strategic decisions or to lack of fuel. And I don't know whether, Charlotte, you or Helen know the answer to that.
I actually, if you give me control, if that's all right, Charlotte, if I field this one, I can show you the perimeter of the roads. You know, we were working with a prefab map here, and you know, it was one of those things of how much detail do we include and how messy do we want this map to look at by superimposing the treatments and everything else on top. But what I can show you from that map is that, if I use the highlighter here, this perimeter here, that's a road. This perimeter here, that's a road. Okay, so Tohono Canyon Fire was definitely contained within the area of the preserve, as were these other two fires in terms of where the preserve was using the road system. And those are dirt roads, of course. But and then I believe isn't that right-hand road? It goes sort of out this way too.
Yes.
And so those are definitely on the preserve. That was the case. However, when you get out into these areas here, those are not roaded areas at all. And you can see as well with the Rock House Fire and its magnitude, I mean, there are multiple ranchers that are adjacent to all of that property. And I know I actually spoke with several of them after the fire, and it was very difficult to contain. And so you can see how the Rock House Fire, really, they didn't have any kind of road system in place in a lot of those places to deal with it. But so yet I don't think it was necessarily a fuels-driven. And actually, I'm sorry, I believe that this is a road too. Isn't that 180? That's 118 that comes out this way. That's the highway. So yes, it was the overlap. I'm sure there would have been swap over, but they did use it was a strategic decision to try to use those existing fuel breaks.
Okay, great. So I'll go ahead and unmute the line. And maybe Susan Rich, do you want to expand on your question? I saw that you're asking about a little more info on the impacts of treatment on species composition.
Yeah, I had somebody come into the office right when you were presenting on that. So I was wondering if there was somewhere we can go to look for more detail on your findings in that regard.
Yeah, absolutely. Well, so are you referring to just the treatments, or you're talking about the treatments?
I think when you were talking about how to keep in mind when we're thinning what the impacts, potential impacts. Changing the species composition over time post-fire.
Yeah, I mean that's actually what we're going to. I mean, I think the 1 year post-fire data is really going to help a lot with that. To say, okay, well, did it change, or did things come back, or was there regeneration? And that didn't include the seedling information. That included only the mature tree data. So if we were to include the seedling information in those importance values of the tree density information, that probably would be very useful as well. So, but the idea being that looking not only changes in forest stand structure, but also looking at changes in species composition and thinking about, well, how is that altered? Is it altered from management? Is it altered from post-fire response? Are questions that we need to kind of delve into more.
Okay. So it's stay tuned.
Yeah, I think so. I think that's the answer.
Okay, thanks.
Are there other questions out there?
So I had a question. This is Pepe Iniguez. I mean, what I get from all of this is that one of the things that I think is interesting is that when you did the kind of the fire surrogate, that can be classified as a fire. But the effects were so different compared to a wildfire, and I think that it probably has. I'm sure it has to do something with severity. I think that that's kind of something that is really important to kind of convey to other people that fire is not just fire. The severity, fire burns very differently when you burn it and stuff like that. So I think that there's a big debate that fire, we can't thin with fire alone. But I think that, I think this proves that you can. It's just the type of fire that you use.
Yeah, that's a good point. And Charlotte, I don't know if you want to answer, or I can, or.
Well, yes, I agree. There's been a lot of work looking at growing season fire versus dormant season fire in a lot of different systems, not just the Southwest, and the effects definitely are different. The thing that we struggle with as managers is how to implement growing season or other higher severity prescribed fires in a way that we can control within the boundaries we plan, and that's also safe for the people implementing the fire. But that's definitely something we're looking at.
Yeah, I mean that's definitely the challenge, right? Obviously, from the just the fire surrogates data, it was fairly obvious that the low intensity surface fires, especially when we were in the field, like everything lived. I mean, and it was actually pretty rainy the season after they did the prescribed fires, and so. I mean, all of the pinyon pines had new growth at the top of them, and so they obviously weren't very stressed out at all from those winter burns.
Other questions? Well, maybe I'll jump in. I'm interested in those refugia, the canyons, and this may not have shown up in the data, but just from your personal experience on the preserve, in areas where the one of the fires burned through those refugia, was it a fairly intense fire? I mean, you talked a little bit about worrying about losing some of those mesic canyons, and did you see that happen in some of these fires?
I do think that in general, the fire severity was higher in the canyons. Again, it varied just like it did across the rest of the landscape, but I'd say on average it was probably more severe in the canyons, probably because the vegetation was more dense. It's a wetter area, so there's more stuff that grows there. And a lot of those canyons are also very steep, so I think that also makes it a little bit easier for fires to get up into the canopies and go from surface fires to crown fires.
Right, I would agree with Charlotte. Interestingly, the thin plus wildfire, some of those plots were in Road Canyon, and so that was actually something that was tested in this study, was to look at whether or not treating these canyons had a differential effect, whereas other canyon like Toad Canyon had no treatment and the whole canyon got torched.
So that seems to suggest that thin and burn might even be in addition, you mentioned thinning around some of these canyons, but it might even be a management option to thin and burn within them?
Yes.
Yeah, I mean, basically what the TNC got a grant to thin one of these large side canyons, and it was funny. It was one of those situations where I was literally putting in plots in front of the saws, So, but yeah, then to be the wildfire element. I mean, the burning, the prescribed fire element would have been a nice implementation to subsequently use afterwards, since it suggests that like other people have found elsewhere, that it sort of seems like the most effective in terms of lowering fuel loads.
I have another question about the refugia, the canyons. Since oak is likely present in some form, it seems to be fairly prevalent in that area. Is that what's coming back? Or can you tell yet?
From my experience, I mean, Charlotte was out in a lot of these spots too. From my experience, yes, you see lots of, in places that got torched, it's getting converted to an oak woodland. But even in that picture that Charlotte showed that had the dead ponderosa pine, snag that was broken above the UBH, in the background you saw ponderosa pines that were still alive. I think the main concern, if I understand correctly, Charlotte, and correct me if I'm wrong, was to say, okay, well, what happened in these music canyons? Did we lose our big ponderosa pines or didn't we? And it doesn't look like we lost all of them. There are lots left. And in some places, the fires didn't burn that hot in those locations.
And this is definitely not the end of this project. We realized that 6 month and 1 year data after a fire doesn't necessarily give you the long-term picture. We definitely had ponderosa pines that survived. Now what we're interested in is whether they will regenerate now that the overall tree density is higher, but you also have this very dense resprouting by the oaks. So we are hoping to continue collecting data in these areas long-term to see what kind of regeneration we're getting, particularly from the pine.
I had a question. I mean, just a general question about just the whole experience. So before the fires occurred, I'm assuming that the preserve, everybody in the preserve was very kind of scared of the wildfire and trying to see what the different options would be. And then the fires occurred. And so what's your general sense now? Was it a blessing in disguise, or you wish you had treated more of the area?
It really depends where in the preserve you're standing. If you're standing in one of the canyons that got absolutely torched, it's a little bit heartbreaking. It's very different from what it was before. At the same time, as I said, across large areas of the preserve, the wildfires thinned a lot of vegetation for us so that we don't have to go do it. So I think it really depends on the perspective, whether you're concerned just about the ponderosa pines that took a pretty good hit and we're still concerned about those even in the unburned areas with the bark beetle outbreaks and the drought. We found some long-eared owl nests on the preserve. We're not sure if those were there before. It's very rare for them to nest in the Davis Mountains. We found 2 this past spring. We're not sure if they were there before and we just couldn't see them because the vegetation was dense, or if that is a response to the wildfires. We are collecting data on the bird community to try and see whether there are any shifts in bird species composition, but it's still too early to tell for a lot of those things. And looking at the chat window at Dave's question about exotic plant invasion, so far we're not really seeing anything on the preserve. That is always a concern after wildfire, but so far things look pretty good.
And Susan Rich also had a comment in the chat window about bark beetle in the ponderosa pine adjacent to the fire sites.
Yeah, I mean, Charlotte, you were there more recently than me. I didn't. I mean, when I was there just right after the last Livermore fire, so I don't think that I saw that, but.
I don't think I saw it either. It's a little bit hard to tell because it's such a large preserve and it's hard to go everywhere on it. My sense is we're not seeing more bark beetles, but it's also fairly soon after the fires, and looking out across the slope, sometimes it's hard to tell the very recent kills from the kills from a year or so ago. But so far we're not seeing more bark beetles adjacent to the fires.
Right. And just to sort of reiterate what Charlotte said when she was commenting on Pepe's point, is that there was a lot of variability across the landscape, and so when you're driving and you're up to get to the top, you will see these tree skeleton mountainsides, and it is. I mean, I was completely depressed after I saw that, but then hiking to my plots, I realized that there was a lot of variability too. And so, you get to these spots, you'd be hiking through this completely torched area, and then of course you'd have this spot that was like right outside the burned area that didn't even get burned. And so, I think that matrix is it's the nature of fire. The fire is patchy. So the question for me, it's kind of from a landscape scale perspective, what's happening, right? We have these species of interest that we want to make sure that we maintain their regenerating populations because they're rare across the landscape. But from a landscape scale perspective, what does this mean in terms of forest regeneration, forest ecosystem dynamics over the long term?
Well, what was the percent of high severity in the preserve?
Well, so we still have to. So actually, Deanna Kreider is working up a fire severity map for this area. She's been validating it all summer. So we're going to tie in with that. And then we also, what I didn't mention in one of my slides is, of course, we have all this score char height data as well. And so I'm going to be looking at the relationship, probably doing just a very simple regression analysis to look at the different changes in tree density and basal area in relationship to fire severity using just sort of the standard sort of fire severity measures, plus then superimposing the plot locations with the fire severity map once that comes out in December.
Okay. I think I was just thinking about that. This area does have a big, commonalities with the Sky Islands in the southeast Arizona and New Mexico. But it also, I think, in 2011 there was huge fires in Mexico that burned a lot of the same country. I wonder, I think that would be a cool comparison too.
Right, and I actually, in Carmen, down right across the border, Deanna's also doing a fire severity map for the Poulos, but I don't have plots there particularly. But that was actually, I told Sandra that I was going to do a shameless plug at the end, which is there's the potential RFP for JFSP to look at these restoration treatments and effectiveness. And so, it would be great if there were other people in the Southwest who are working on some of these kinds of questions to try to put forth a more kind of synthetic and regional proposal to try to look at some of these questions.
Well, maybe we should talk then. Yeah, because we have similar data in the Chiricahuas and the Sky Islands, kind of pre-fire data collected for other stuff that those plots ended up burning, and we're measuring them this year.
Oh, awesome! Yeah, and I did my master's in the Chiricahuas, so that's why when I came to this place, that's why I was like, oh my gosh, this place looks like other places I've worked in the Southwest. It felt very familiar to me, So I think.
So your plots in the Chiricahuas probably burned 2011 too, then, huh?
Yeah, I know there was that big. Yeah, I think you're right. Yeah.
Cool.
And there's also Pinus embroides there, or is it Pinus discolor? I guess it's Pinus discolor.
Yeah.
It's similar.
Yeah.
Good. Well, it's good to have some research synergies. That's part of what the consortium's all about. So we're just about at an hour. We should probably let folks go. But I do want to thank Helen and Charlotte again. Great presentation, and thanks for fielding all these questions. We hope those of you who joined as participants can join us next time. You'll get an email if you're on the email list. And with that, one last thing. When I close off the webinar, you'll be sent to a survey. And if you could just take a minute or two and quickly fill that out, that really helps guide how we can improve these in the future, even whether it's content or the technology. So again, thanks everybody for joining, and we'll look forward to participating with you again sometime.
All right. Thanks, Andrew.
Thank you.
Thank you.